Hello and a big welcome back to all my subscribers. And if you're not a subscriber, why not? Well, today I'm much further along than I was with my hardware. I have now received all of the parts and I've put almost all of them in. In fact, I put all of them in, but I haven't wired everything. However, I was planning to do a simple bit of wiring where I just wire the address lines of the 68K into the ROM so that it would run a really simple program that I would write just to test. Now, this appears to be junk that is just left in either the CPU or in the ROM. I'm not really sure. But if I hit the reset, it goes away. However, it is not what I wanted, because what I wanted, and I'll show you later in the code, was to basically change these lights so that they were sort of alternating on and off. And that way I would just be able to check at least the address lines, and then I could do the same thing later with the data lines. But my initial thing was to just get the address lines working. The snag and the hiccup that I ran into, well, yesterday evening, was that I realized that the multiplexer on Y0 should be low whenever the thing starts up, so that it will look at the first address 00000. And then that is ANDed with the reset, and in theory would produce a low signal, but in fact it did not. It always produced a high signal, and it was because I just did a stupid thing with my logic, and rather than having it in an AND gate, I actually need it in a NAND gate. So I've had to add a NAND gate up here, and then I'm going to wire that up for that signal to get the logic right. And the idea here is that the chip select for these chips is on low of Y0, which basically means the first address. So whenever the thing starts up, it's going to default to the first address space 0000. That's the idea, but let me show you some of the code. So the plan here for the code, as you can see, the origin is just 0, and then this is be the top of my stack pointer when the thing actually is live. Now, most of the rest of this we can ignore, because it will only happen if I comment out all of this. So I am going to move the stack pointer, but then after my first test, after the lights, this will all go away. I'll delete all of this, but just to show you what I'm doing, I just want to move something into the address line, and in this one, this will come out as in binary. It'll be sort of 1111 and then 01010101, etc. And then it loops through that for a little bit, just to give me human time to see it, and then it moves this in for the second loop, and that is basically the opposite of the other one. So this will be, instead of 0101, it'll be 1010, etc., etc. And then that loops for a little while, and then it just jumps back to start so that it does all of this again. Now, that is what I plan to just stick in there initially, so that I can run these tests. on the board itself. But with the board, I absolutely have to get it working better. However, having said that, I'm much further along than I was before. Still don't know why it does that on power up, but doesn't do it on reset. So if you know, let me know in the comments what's happening here. But basically, it's all in now, and I can show you the components that will eventually all get wired up. So I have LEDs on the address lines, I have LEDs on the data lines here. This is the RAM, and I'll have 4 megabytes, and then this is the ROM, and it's also 4 megabytes. I'm actually planning on getting some ZIF sockets for these. I've ordered them in because this is just too fiddly to take in and out all the time. There's the 8 megahertz clock. This is the new NAND gate, and then I have over here an AND gate and an inverter reset button. This is the reset chip, which also has a watchdog on it. This is the multiplexer, which is basically doing all the control I was talking about. So Y0 is the ROM, Y1 is the RAM when it wants to read from RAM, and then Y2 is, I think it's the UART, and then Y3 is the VIA chip, and then Y4 is the GPIO, etc., etc. So that uses the top 4 of the address lines to set the 4 pins here to work out the where it's going. So clock, NAND gate, RAM, CPU, ROM, inverter, AND gate, reset switch, multiplexer. This is the VIA chip, and so almost, well, in fact, all of the SPI devices will run through the VIA chip. And then the UART, which is actually the one I changed to a DUART, so it's a dual UART, and it'll do a 10-pin serial and a 6-pin serial. And I think 6 pins channel B and 10 pins channel A. Then I've tentatively put in a slot for my SD card. So the SP SD card, and that will need to be wired up. This is for the mod VGA, so that I can get if you remember, so that I can get the VGA output and also a keyboard PS2 output, by plugging this into there. These are all the level shifters to go from 5 volts to 3.3 and back. And this is the DC buck converter that converts the 5 volt down to 3.3. And then these are just the switches, effectively, for the GPIO. So realistically, what happens here is these are written to the read-write of the CPU. When it wants to read, it sets the direction on these 2 chips, and it sets the direction from B to A, which is from here into the CPU, or when it wants to write, it sets it from A to B, so it goes from here to here. So this is all fairly well done. The only bit that really needs to work now is all of the address lines and all of the data lines. Now the control signals, in theory, bar that one I found that was wrong, have all been wired up. Now I have to rewire that one, and I'm just going to double check all of these to make sure that I've got them all correct. But I've only got, 4 control signals out of this, so it's not really that difficult. So I'll double check all of those to make sure that they're all working correctly. And then off we go. So at that point, my code here should work, and then once I'm sure that this bit works, i.e. it can read from the it can set the addresses and basically this is reading from ROM, I'll be all done. So that's it for me today. Thank you very much, and I'll see you soon.